All right, guys, so here we are, 9.2. We're kind of continue our discussion on parallelograms here. And I like to think of this lesson as shortcuts, or what are some shortcuts that we have to basically prove that a figure is a parallelogram. Okay, and again, it's called conditions, right? Conditions for parallelograms, right? So there are 5 ways that we're going to go through to show that this quadrilateral, okay, or that this 4-sided polygon is a parallelogram. Okay, so let's go ahead and kind of get to it here, right? So we're going to be making lots of markings and different things on how this will look in a diagram. So here's the first way. Okay, we can show that both pairs, okay, of opposite sides and show that they have the same measure. Okay, so the question that we're going to look at is, well, how is this going to look on a diagram? Okay, well, let's take a look at this quadrilateral ABCD. Okay, to show that both sides, both pairs of opposite sides are congruent, it might look something like this, right? If we have 2 tick marks here on the opposite sides there, so AD and BC, maybe I put 1 tick mark here on segment AB and then another one here on DC. So those markings show that both pairs of opposite sides are congruent. So we answer the next question, which pairs of segments do we need, okay, to show congruent to prove that ABCD is a parallelogram? Well, let's kind of write down what we just marked. We need to show that segment AB is congruent to segment DC. Okay, and the other thing that we need to show here is that segment AD, okay, we have to show that that's congruent to segment BC. Okay, so pretty straightforward, right? If we can show those 2 things, we can conclude that, this figure is a parallelogram. Okay, now let's go ahead and look at the second way. Okay, the second way that we can show that a figure is a parallelogram is we can show that both pairs, okay, of the opposite sides are parallel. Okay, so there's certain markings that we need to be able to show in order to basically do this, right? So the way that we show this is kind of little arrows on these segments. So there's 1 pair of opposite sides that are parallel, okay, and then here would be the second pair of opposite sides that are marked as parallel. Okay, if we can show that both pairs of opposite sides are parallel, hey, this thing is a parallelogram. That's all we need to do to show it. Okay, so let's go ahead and kind of write down what we just marked, just as we did before. We would need to show that segment AD is parallel to segment BC. Okay, and the other thing that we would need to show, that AB, okay, or segment AB rather, is parallel to segment DC. Okay, and that pretty much does it there, right? So that's the second way that we can show that, a given quadrilateral is a parallelogram. Okay, now let's kind of talk about this, right? When we have parallel lines, there's all sorts of things that we've covered this year, and I'm gonna, just to make this process go like a little bit quicker, I'm just gonna kind of type this stuff out. So let's see here. Which stuff have we learned before that's going to help us show parallel sides? Or which theorems have we talked about? Well, we know that alternate interior angles are congruent. Okay, and obviously, we would do some different markings for that. Okay, another thing is if we know that the alternate exterior angles are congruent. Okay, if we could show that, then we can conclude that lines are parallel. Another way, if the corresponding angles are congruent. Okay, if the corresponding angles are congruent, then we can show that lines are parallel. We also have if the same side interior angles are supplementary. Okay, and the last way that we've discussed on how we can prove lines parallel is if the same side exterior angles are supplementary. Okay, so if we can show any of these things given a certain diagram, okay, we can prove that we're going to have, or we're actually working with parallel lines. Okay, I'm going to do the best I can with my penmanship here. Okay, so those are kind of the 5 ways that we talked about. You know, I don't even remember what module it's in, but it was a little ways back. Okay, and that's some stuff that we may be using, you know, throughout these types of problems to show that we're actually working with parallel lines. All right, so let's go ahead and talk about more of these conditions here. Okay, you know, we'll go through these kind of quickly here, but you know, number 3. Okay, if both pairs, okay, let's go ahead and change colors here. What if both pairs of opposite angles are congruent? Okay, how would this look on a diagram? Well, if we had something like this, and we have one arc mark on angle A and another one on angle C. Okay, and then if we had 2 arc marks on angle D and its opposite angle, angle B. Okay, if we could show this in a diagram, we can say, hey, this figure is a parallelogram. Okay, so kind of writing this down, which pairs of angles do we need to show congruent before we can prove that we're working with a parallelogram? Okay, again, we would want to show that angle A is congruent to angle C, and we would want to show that angle B is congruent to angle D. Okay, if we can show both of those things, we know that we have proved that a figure is a parallelogram. Okay, pretty straightforward. Okay, just memorizing these 5 rules will be a little bit of work. Okay, all right, so yeah, we can go ahead and continue here, right? So number 4, okay, so we're on condition now 4 of 5. If we can show that the diagonals, okay, diagonals bisect each other. Okay, now we haven't used the word diagonal a bunch this year, but basically it's just a segment that goes from a vertex to a non-consecutive vertex. Okay, so basically one angle, we have to skip an angle and go to the next angle. Okay, and how would this look on a diagram? Well, let me go ahead and grab a segment here. Hopefully this can make my picture a little bit neater. Okay, so these would be diagonals, right? So again, going from one vertex to a non-consecutive vertex, and here would be the other diagonal. Okay, and then we basically want to mark up how this is going to look if the diagonals actually bisect each other. Well, here's how it could look. Okay, maybe I'm going to go ahead and maybe mark this point of intersection as point E. And I'll go ahead and I can put a little dot there. Right? That's that point of intersection there is point E. Okay, so if I can prove that AE and EC are congruent, okay, and then also that BE and ED are congruent, okay, then these conditions are met for this to actually be a parallelogram. All right, so we'll go ahead and just write down what we just marked. Okay, if we can show that segment AE, okay, is congruent to CE, and that segment BE is congruent to segment DE. Okay, then we have met these conditions and we can prove that this is a parallelogram, that this figure is a parallelogram. Okay, and then finally we're going to go over to number 5 here, right? So show that one pair of opposite sides are both congruent and parallel. Okay, so we just have to follow the directions kind of closely on this one, right? So one pair of opposite sides are both congruent and parallel. Okay, so what if maybe we choose the one pair of opposite sides? So let's go ahead and say they're congruent first. We're just kind of following their directions. Okay, and they need to be both congruent and parallel. So we would then go like this. Okay, and then make our little marking there with the arrows that show that those 2 segments are parallel. Okay, so kind of answering the same question, which segments do we need to know, or do we need to show congruent and parallel? We can say that segment AB must be congruent to segment DC. Okay, and we would want to show that segment AB is parallel to segment DC. Okay, again, hopefully my penmanship is okay here. I think it's even a little bit better if I were actually writing on the board. Okay, so again, those are the 5 conditions, right? So you want to be able to look back through those and make sure that you're taking good notes. And the more practice problems that you do, I think the easier it will be, to make sure that you understand these. Okay, so now we're going to go ahead and kind of solve a couple problems here, right? So we want to basically go through, are these quadrilaterals parallelograms? If so, we want to explain. All right, so here we go. The first one, right? I see that it looks like these are diagonals drawn, and it looks like we have some congruent segments here. So I'm going to go ahead and say yes for this first one. This is one of the conditions that we talked about. Okay, if we're explaining why, we could say that these diagonals I'm going to abbreviate here, but these diagonals bisect each other. Okay, so the diagonals bisect each other. That was one of the conditions, and so we could conclude based on this information that that is a parallelogram. Okay, on this one, okay, this next one, what we have here is that we have two pairs of opposite sides that are congruent, right? So we would say yes. Okay, we'd say yes, these are parallelograms. Okay, and then I'm basically going to say two pairs, okay, of opposite sides are congruent. Okay. And we can just kind of keep going through these, right? So, you know, what information do we have? This one, you know, for this, I guess it looks like part E might be a little bit more tricky, but here's kind of what we got here, okay, is that we have a couple of angles that are marked congruent here. And so I'm going to kind of just sort of extend these lines and take a little bit closer look at this. Okay, the relationship between these lines here, between these angles, that are marked congruent are alternate interior angles, okay? And so if those alternate interior angles are marked as congruent, then we can conclude that these lines are parallel. Okay, so I'm going to go ahead and mark these as parallel. And then what you can see from this figure is that now both sides are parallel, right, from that given information there. So we would say yes. Okay, and we would say again, we would say two pairs of opposite sides, okay, are parallel. Okay, so that's why we can say, hey, we're dealing with a parallelogram here. Okay, this one's looking like the fifth condition over here, so I'll change colors to purple here. So it looks like we have one pair of opposite sides that are marked as both congruent and parallel. So we would say yes again. Okay, so yes. Okay, these are, this is considered a parallelogram, okay? And I'll say again, one pair, the reasoning, one pair of opposite sides, okay, are congruent and, let's write it out here, and parallel. Okay, and finally this last one, okay, you can see that we have one pair of opposite sides that are parallel and the other pair of opposite sides that are congruent. Okay, and the answer is that we can't quite get there with that information, right? That wasn't one of the 5 conditions that we discussed, so we would just write no. Okay, so now we just kind of want to look at these and you know, be able to solve these problems. All right, so here's what we're going to do is we are just going to show that each quadrilateral is a parallelogram for the given values of the variables. Okay, so essentially what we're going to do is we're going to plug in 7 for x and then 4 for y, and we're just going to make sure that one of these conditions are met. Okay, or in these cases we're going to have 2 pairs of opposite sides that are congruent. So if I want to basically compare BC and I want to compare that to let's see, BC and AD. Okay, the representations given in terms of x are x plus 14. Okay, and the other one here is 3x. Okay, well, if I go ahead and plug in 7, that would be 7 plus 14. Okay, is going to be equal to 3 times 7. Okay, and both of those are equal to 21. Right, so again, we've basically proved that we have, you know, one pair of opposite sides that are congruent. Now, to do this again, right, we would say, all right, well, that doesn't quite give us a parallelogram. We got to be sure that you know, AB is equal to you know, DC. Okay, so we go ahead and plug in you know, these lengths in terms of y. So I'd say 5y minus 4, okay, is going to be equal to 2y plus 8. Okay, I'll plug in that value for y that was given, so this can be 5 times 4 minus 4. Okay, and that has to be equal to 2 times 4 plus 8. Okay, and to keep a long story short, both of these are going to end up being 16. Right, we just followed the order of operations there with multiplication and then addition or subtraction. Both of these equal 16. Right, so because we've shown that we have 2 pairs of opposite sides that are congruent, we can conclude, hey, this is a quadrilateral. Okay, something similar for part B. right? So it looks like we have 4 given angles, okay? And in this problem, it looks like we want to show that the opposite angles are congruent, okay? If those 2 pairs of opposite angles are congruent, then we can conclude that this figure is a parallelogram. Okay, so we'll go ahead and do this, and I'm going to keep this pretty quick, right? But we got to see if angle F is equal to angle H. Okay, so if I plug this stuff in, it's going to be 9z plus 19. Okay, is that equal to 11z minus 3? Okay, if I plug everything in here, what I'm going to end up getting, 9 times 11 plus 19. Okay, that's got to be equal to 11 times 11 minus 3. Okay, and I'm just going to use your calculator to kind of simplify this and solve it, right? So order of operations here, guys, would give us 118 is equal to 118, right? So we would see that those opposite angles for F and H anyways are congruent. And we'll do the same thing with the other ones, right? We got to show that angle E is going to be congruent to or equal to rather. Kind of almost the same thing, but angle E is equal to angle G, right? So we have now 12W plus 8. Okay, and we have to show that that's going to be the same thing as 14W minus 1. Okay, and the value for W is 4.5, so we would substitute that in. Okay, 12 times 4.5 plus 8. Okay, and that's got to be equal to 14 times 4.5. Okay, and then I subtract 1 from that value. And I like to use little mental math tricks for this. I'll cut 12 in half and then double 4.5, right? So it's basically going to be 6 times 9, right? Or 54, and 54 plus 8 we get 62. Okay, obviously using a calculator works as well. We would get the same thing here, right? So 14 times 4.5 is the same thing as 7. 7 times 9, we subtract 1, and we'll find out that that is also 62. Okay, so again, what we basically showed here, right, is that the opposite angles are congruent, and so because both pairs of opposite angles are congruent, then we can show that that this is actually a parallelogram. Okay, so now let's kind of look at a proof here real quick, right? So how we may actually work through this, right? So we're given a couple different pairs of angles that are congruent, and we're supposed to prove that this is a parallelogram. Right, so we're looking at statements and reasons and working through this as a 2-column proof. All right, so the first statement that we would have that I would use is I would use this piece of given information. So angle XRV, okay, that is going to be congruent to angle RST. Okay, now what I would do from here is just write out the fact that this is given, but I'm thinking to myself, what information can I conclude from this, right? Or what do they just tell me? So try marking your diagram. XRV is right here, okay, and then we have let's see, RST is right here. Okay, so I'm kind of thinking, those look like they're in pretty similar positions. Okay, so I'm going to kind of pull my highlighter out here and just sort of extend a couple things. I have these two right here. Okay, and then maybe this is the transversal. Those 2 angles that I just marked as congruent, they look like they're in corresponding positions. Okay, they're both, I guess, kind of like to the right of their respective lines, and they're both above the transversal. Okay, so what I can sort of conclude there, based on that information and based on previous theorems that we've used, is that these are actually parallel. So that's going to be my next statement. Okay, that's what I would put as my next statement. So for statement number 2, I'm going to say that segment ST is parallel to segment RV. Okay, and our reasoning here is that if the corresponding angles are congruent, then the lines are parallel. That says parallel. Okay, so not too bad there. We kind of showed one thing, so we think about what conditions we might want to try to show. But we can also look at what's the other information given to us. So I'm going to switch colors just because we're kind of switching gears to another piece of the problem. Angle RSV is congruent to angle TVS. So I can say angle RSV is congruent to angle TVS. All right, so from there, we want to say, all right, well, that's given information. That was kind of helpful of them. So nice of them to give us that information. And let's mark the diagram with that information. So RSV, that's this angle right here. Okay, that is congruent to angle TVS. So TVS is right here. And we start asking ourselves, oh, okay, well, what is the relationship between those angles? Okay, well, I'm going to kind of switch colors here so hopefully we can see a little bit better. So I'll go to my highlighter here and maybe I'll go with purple. Okay, well, if we think about these two lines, so one right here and the other one right here, and we think of this as the transversal. Okay, those two green markings that I just did for those congruent angles, those are alternate interior angles. And if we can show that those are congruent, then that shows that we are working with parallel lines. So I'm going to go back to the pen here and I can mark these as parallel. Okay, so now I can go to statement 4. So statement 4 is going to be that segment TV is congruent to segment SR. Just kidding. Sorry about that. I went on autopilot there. Okay. Segment TV is parallel to segment SR. Okay. And our reasoning is that if the alternate interior angles are congruent, then the lines are parallel. Okay, and fine, that's enough information, right? That was one of our conditions. If we can prove that both pairs of opposite sides are parallel, then we have a parallelogram. So let's do our final statement. Okay, let's make, I'm just going to scroll up just a touch here and make sure I know what it is. RSTV is a parallelogram. So RSTV is a parallelogram. Okay, and then the reasoning is basically one of those conditions that we wrote down, right? If both pairs of opposite sides are parallel, then it is a parallelogram. All right. So, you know, kind of just building on previous knowledge that we have, right, and just sort of connecting it to this particular lesson. All right, let's look. I think we got one more problem here to kind of work through. Okay, so we'll go ahead and kind of just analyze this problem. It looks like they're giving us side lengths, and they are asking us to determine is this a parallelogram, and if so, how do we know? Okay. Okay, so it looks like let's go ahead and mark the diagram with the information that we know. Okay, so it says AB is 17, right? So we'll go ahead and mark that in. Okay, it then says that BE is 2x plus 5. So I will write that in. 2x plus 5. Okay, BC is 5x plus 10. Okay, and then BD is 3x plus 2. Okay, so again, we got to think about what information do they give us here and how can we use it to solve the problem. Okay, well, one of our conditions just said that if the diagonals bisect each other, then it is a parallelogram. Right, so we basically want to figure out the value of x, and if the value of x makes these two pairs of these congruent segments, then we can conclude that B is a bisector of both of those diagonals, and so that's the condition that we need. So what I'm going to do is I'm just going to set up that AB, it should be equal to BD. Okay, and we'll solve this simple equation here. So I'm going to say that 17 is going to be equal to 3x plus 2. Okay, if I were to subtract 2 from both sides, I would get 15 equals 3x. Okay, and I would get, if I divide by 3, I'd find out that x is 5. Okay, so just to be thorough here, I'm going to do this with the other ones as well, just to be sure that we get the same value of x. So I will set that EB is going to be equal to BC. Right, I'll set 2x plus 5 is going to be equal to, let's see, 5x plus 10, 5x minus 10. Whoops, I marked that diagram wrong. Sorry about that. 5x minus 10. I was going to say that didn't look like it was going to be quite right. So sorry about that, guys. I got to mark the diagram correctly. Anyways, if we solve this, right, I would subtract 2x from both sides, and I'd get 3x over here. If I added 10 to both sides, I'd get 15 over here, and I would find that that x equals 5. So, okay. Good to know that I got the same value of x for both of those. Okay, so now I can start plugging things in, right? So 3 times 5 plus 2, that would be 17 here. Right, so it looks like we have 17 both here and here, so that's a good thing. That would mean that we have congruent segments. Okay, so that's a good thing, right? I'll go ahead and plug in 5 over here, right? So this would be now be 2 times 5 plus 5, right? Or that would give us, it looks like 15. Okay, so I get 15 on this one. We just got to make sure that we get the same thing over here. So if I plugged it in over here, I would get 5 times 5 minus 10, or 25 minus 10 is also 15. Okay, so again, that shows congruent segments here and here, right? And so our conditions are met. Our conditions are met for this to be a parallelogram. So I can go ahead and just say, yes, the diagonals bisect each other. Okay, kind of a long lesson, kind of a long video, but hopefully you guys kind of get the idea. Go ahead and get started with your practice. Have a good day.